Chapter 7, All the Small Things. Here we go. I used to call this chapter Solar System Debris. Solar System Debris. Let's talk about things other than planets and moons, essentially. Starting with asteroids. A lot to talk about with asteroids. Now, what is an asteroid? It's a rock. It's orbiting the sun independently. If that rock was swept up by a planet, we would call it a moon. But when it's independently orbiting the sun, we simply call it an asteroid. They are undifferentiated, meaning they don't have layers like core, mantle, crust, like a lot of planets and some moons have. They have very eccentric orbits, meaning they're not very circular. They're more stretched out, more elongated, between, of course, Mars and Jupiter. Not all of them, but the majority are between Mars and Jupiter in what we call, of course, the asteroid belt. One big misconception is that there's, a lot of material in the asteroid belt. For example, it was thought long ago that perhaps a planet was destroyed, and that's what made the asteroid belt. But that doesn't pan out. If you take your space bulldozer and just pile up all those rocks, you're not going to get a planet. You're not even going to get a large moon. You're going to get the mass of 1/10 of our moon. So there's even though there are a lot of pieces there, you pile them all up, there's really not that much material there per se in terms of mass. The largest asteroid, and possibly the most interesting one, at least in my mind, is Ceres. Ceres, and it is large enough that gravity pulled it together into a spherical shape, which is important because Ceres, when Pluto sort of got demoted back in 2006, I like to say that Ceres got promoted to dwarf planet. So it is not only an asteroid, it's the only asteroid that gets to be classified as a dwarf planet, and that is, again, because it's spherical. It's pretty big. I mean, it's just under 600 miles in diameter, so larger than any U.S. state, let's put it that way. I'm not sure about Alaska, actually, but anyway, to give you some rough scale, but still only 1/10,000th the mass of our Earth. 1/10,000th the mass of our Earth. Here it is from the Hubble Space Telescope. We have better pictures now that we've actually been up close to it with the Dawn spacecraft, but you can at least see from this image in 2004 that it is spherical versus Vesta, which is, I think, the third largest asteroid. Looks more like a typical asteroid. All right. Okay, there's a better picture of it, and you can see, look at that. I mean, it's only about less than half the diameter of Pluto, which again is also now classified as a dwarf planet, and that's kind of cool. You can compare it in size, let's say, to our moon. Not even close, not even close, and to the largest moons. That one right here that says 2003, that's actually Eris, E-R-I-S, before it had its common name given. All right. This is a picture I took in Rome of a statue of Ceres, who was the goddess of grain, and hence where we get the word cereal, which is kind of neat. Ceres. All right, so in this case it is differentiated. I said that asteroids aren't differentiated or undifferentiated, but Ceres is, again, makes it kind of special. That it has a somewhat of a core mantle crust situation. Beginning to think that there could be, as it seems that water is more and more prevalent, that you could have possibly an underground ocean there as well. I mean, that's not as likely as certainly we know what's the case with Europa, but interesting stuff there that we may find eventually. Interesting history tidbit here, the Titius Bode law. Some mathematicians a couple hundred years ago had predicted, based on the fact there seemed to be kind of a gap when they were looking at the spacing of the planets mathematically, there seemed to be an extra large gap between Mars and Jupiter. And so they predicted that we would find a planet there, which is kind of why we were looking in that area of the asteroid belt. Now, that's not science. I mean, that's not how this works. You don't just this was just more of a random guess based on nothing particularly logical. But anyway, that's why I put law in quotes. It's not a real law of nature. There didn't have to be something sitting there. But there was. Now, it wasn't a planet, but it was the asteroid Ceres, right about where they predicted. So an Italian astronomer named Piazzi discovered Ceres in 1801. Now, in 1801, if you find an object orbiting the sun, what vocabulary do you have available? What are you going to call that object? Well, there's only one term. Planet. Right? It was the first, what we now call asteroid, discovered, but that word didn't exist, so they called it a planet. In 1801, Ceres became the 8th planet going around the sun. Now, keep in mind, Neptune was yet to be discovered, so it was the 8th planet at that point. However, not long after that, they discovered Pallas and Vesta, and throughout the 1800s, they kept discovering other objects. Today, we know there are over 100,000 rocks out there, and so at some point, they said, you know what? These things are not very big. Most of them, I mean, they didn't know this at the time, but they're not round, they're not very big, they're not very massive, and there are going to be a whole bunch of them. Let's just come up with a new term. This story should sound familiar. It's exactly what happened with Pluto. Pluto was discovered. It was called a planet for decades. And then once we started finding other icy objects out by Pluto, we decided to change the definition. And that's what happened here. So Ceres got demoted from planet to asteroid. Aster simply means star. So to me, it's not a very good, very appropriate name at all. It sounds cool, but not really an appropriate name. So I mentioned the asteroid belt is where most of them reside, and they have prograde orbits, meaning they orbit in the same direction that the sun spins, that the planet orbit the sun. Prograde orbits. Here's a nice looking map of where most of them are there in the asteroid belt. You notice it hovers a little closer to Mars than to Jupiter. However, there are exceptions that we'll get to in a little while, including the Trojans and the Greeks, which are each in front of and behind Jupiter. They orbit with Jupiter. They're not orbiting Jupiter. They're not moons, but they orbit at the same distance as Jupiter from the sun. Very interesting. 120 degrees apart from each other, and then 120 degrees apart from them, the Hildas, another small group there. So those are some exceptions to the asteroid belt. All right, there are three major types of asteroids. C-type are of most interest to scientists because they have carbon, the stuff that life is made of. And they are dark, and they are primitive, meaning they haven't been changed by volcanoes and water and wind and stuff like that. So scientifically, they're like a fossil. They tell us what the early solar system was like, and most asteroids fall in this C-type. S-type are kind of boring. They're just sort of normal rocks, not quite as interesting scientifically. S-type, occasionally you'll find one with an interesting shape or something. Here's one that has an interesting shape, Cleopatra. Seems like they missed a good opportunity here to name it something like the dog bone, especially, you know, since they found it near Pluto. Okay, I'm just joking. I'm sorry. No, that they didn't find it near Pluto. Anyway. Now, M-type asteroids may be of a completely different interest to humans. Nothing to do with science per se, but M stands for metals, and in particular a lot of iron and nickel. We're talking about a lot of iron and nickel. In other words, if you just found one of these sitting, let's say you owned a big ranch, and somehow you just hadn't noticed that there was a mile-wide asteroid, at that point it'd be called a meteorite, sitting in your property, you would be absolutely incredibly wealthy. Now, I don't know what that would do. Obviously, the price would drop as the market's flooded with nickel. But it's not just iron and nickel. There are other things out there, you know, within them. Palladium, I think, is one of the main metals. But anyway, some rare earth metals that are very expensive. And it's my understanding that just one of these, if you could mine the entire thing, would be worth trillions of dollars. That's with a T. So it's well worth doing, and they're just sitting there for the taking. One company that I'm going to mention is called Planetary Resources, and they have a plan to do just that. They're going to do some flybys and see which ones have the most potential for mining. And this is a company that actually has backing by, legitimate people in terms of the money, in terms of the scientific knowledge. So we'll see what happens. It's going to happen. I mean, it's going to happen, and I assume it's going to happen this century, that somebody's going to mine an asteroid. It's just sitting there for the taking. There we go. Platinum was the other thing I was trying to think of. Platinum and palladium would be other more rare earth metals that we would want to mine from an asteroid. Pretty cool stuff. All right. We're really starting to learn, look at this, where these asteroids are. I mean, we're not going to get taken by surprise by an asteroid that's the size of the one that wiped out the dinosaurs. We know where they're at this point. They're really, really large ones. Now, so look at that. Even down at 1 kilometer wide, we know where most of them are at. And these numbers change all the time. Every single year, we find new ones. I've been out to the University of Arizona where they were tracking them, and I was in the room when they discovered one. I mean, they find new ones all the time. So the question marks are getting smaller as far as the really large ones. But look at this. You get down to about the size of a football field. That's where we're in trouble. That's where we could be blindsided by ones that they're not going to destroy civilization, but they're going to make for a pretty bad day for some locale, some city on the earth. Could be destroyed by that. And then you see that when they get really small, then they're all over the place, and we don't know where they're at. And that's a real problem. All right. The WISE, I think, stands for Wide Field Infrared Survey, and it has changed our estimates here on the number of asteroids. And the good news is, look at this. Like, let's just take here in the 500 to 1,000 meter range. Before, we previously thought there'd be this many total asteroids. Now, these on the left, you see how many that we have discovered already. And these are the ones that we had predicted would be out there. But now, thanks to WISE, we can actually pull back that prediction some and show that we don't think there are as many out there as we thought, which is really good. I mean, that's all good news there. And then again, look at this. You get down to the size of the football field, and the amount of error there is huge. We really are kind of clueless at that point. And we're going to end here. Let's take a look real quickly at a couple more. Vesta's a very interesting one because it has signs of volcanism. The problem is, Vesta's not nearly big enough to have volcanoes, so we think that it perhaps got chipped off of some larger object. And we've actually found pieces of it on Earth. So we can test them directly and know that that's the case, that it's truly basaltic material. Interesting stuff. Dawn spacecraft has been an amazing success. It visited Vesta and Ceres, I believe. All right. The Galileo spacecraft flew by a couple of ones back in the 90s as well. Here's one of my favorites from the 1990s where they flew by Ida and discovered that Ida, the asteroid, has its own tiny little moon called Dactyl. There would be so little gravity you could easily jump off of Dactyl yourself, put yourself, launch yourself away from it, and maybe try to float over to Ida. Interesting. Here's a picture from the Dawn spacecraft of Vesta. You already see lots of interesting grooves and so forth, indicating it might have chipped off of something larger. Yeah, I'm sure they're still studying that. A lot to study there. Interesting indentations, obviously lots of craters and stuff like that. And then one thing in particular that caught their attention, look here on the left. Yep, the snowman. The snowman, kind of cool. Probably a single rock that had broken into 3 pieces and bam, 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 created that interesting set of craters. Okay, I think we're going to save the rest of this. Next time we'll talk about the odds of Earth getting hit and what we can do about it and stuff like that. Thanks for listening.